This is the module I removed last time. There's some discoloration down there, so I think I've damaged a cell right at the bottom. So let's take this off, get it at it. So these plastic guards are just for insulation, so you don't touch these on other things as they're installed. These are the cells that I'm using. They're LG E63 cells. They've got the positive on one end and the negative on the other end. And so the way that I've done it is that I've stacked them up in here like so. They need compression. So these, we've got a top plate and a bottom plate, and these threaded rods help us get the compression. 4 in parallel, 6 in series. So there'll be 1, 2, 3, 4 down there. And these tabs, the negative end, are all joined together here. Then there'll be 4 the other way around, 4 the other way around, 4 the other way around, and so on. And so you've got negative, positive, negative, positive, negative, positive, negative, positive. And so you end up with, this is the negative off the entire module, and this is the positive off the entire module up here. So I think I need to get to the cell right at the bottom. So I need to pull this apart to replace the cell. Here's the end of our battery module. So you can see the cells in under there, the ends of the cells. Tabs are coming through in under here. So what we have here is a BMS circuit board on the top. And then under there we have a spring like this one. So that's bent, manufactured to have that bend in it, so that when you bolt it down it will have sort of distribute the pressure evenly over the surface. So that top one in there, you have the tabs coming out in between the aluminium and the steel spring. So the tabs are sitting underneath there and they're being pushed down onto the aluminium. So these 2 aluminium C-sections, they are the main current carrying thing, so you don't expect that much current to go run through the steel. It's all from the tabs into that aluminium. So the top, we've got 8 cells joined together here because we're at the negative end of one's lot of 4 in parallel, and the positive end of the next 4 that are in parallel. And so we just need to connect all 8 together. At the top, we've got the top 2 connected in with their tabs underneath that spring. The middle 4, 1, 2, 3, 4, yep, all have their tabs in between these 2 aluminium bits of channel. And the bottom 2, there's another spring underneath there. And you can actually see those 2 tabs poking out underneath that spring on that one. Now, what else do we have? So the BMS module board needs positive and negative, and it gets its negative from this bolt here, which is bolted directly onto the cells here. Now it's got to get its positive from the other end of the cells all the way over there. And so the way I've done that is with this connector here. So that has 2 wires in it. One of them is for a voltage sense, because it needs to know what the voltage is of this cell, and the other one is for when it's balancing, it discharges some current through these resistors. If I had them both in the same wire, then if it's discharging a lot of current running through there, then the voltage would be incorrect. You get inaccurate voltage readings. So I've had to run 2 of them all the way to the other end. And so if you run all the way to the other end, not that you can really see that wire, oh you sort of can, then it comes through, and on this other end it's bolted onto here. So back where we were looking, you can see these 2 at the bottom here. These are for the next BMS module, which is around the other side. So you've got a module with its negative connection and then the positive connection for the next module on each set. Now with these bolts here, Got a bolt going through. There's a washer underneath it to stop it chewing into the BMS circuit board. Underneath the circuit board there's a washer to make it, to have it clear of the spring. Then there's no washer under there. Then underneath there's a spring washer to stop the nut from undoing. I originally tried to thread these aluminium pieces, but they weren't thick enough and they kept on stripping. So I've ended up having to put nuts on the bottom as well, which means for each one of these there are a lot of bolts and nuts and a lot of time and fiddle. Okay, ready to start disassembly. So on the BMS, these are the communications lines, so that goes to the next one, and then there's another one to the next one, and so on. So I can take these out. BMSs will be sending error messages for all they're worth. So the communications line, and then this one here is the power line. So disconnect that and it'll put it out of its misery. That's right, I put some Kaptan tape on the bottom of these. Somebody recommended that so that we don't have steel to aluminium contact. It'd either be steel to aluminium or steel to copper, depending on which tab we are on the cell. So you can see this is wobbling a bit now with this is just being held on by the tabs. These are really, really solid. Once they've got all 8 tabs in there tightened down, they're really good. With this one, I've got this is the positive terminal of the entire module, and so it's only got one end of this particular group of 4 cells in series, which means it's only got 4 tabs connected to it. So it's got 2 on the top, 2 on the bottom, and so here is where I take my power out of the module. It's done with that copper bar there, which is a bit of squashed copper pipe. You can see how I've done it here. This is the negative end. It's also squashed copper pipe. And if I can get the camera down there, you can see I've done a similar thing on the bottom. And so that pipe just goes up there and sits within. The module, the Perspex cover I had on it helps support that so it doesn't wobble too much. But otherwise it's just bolted to that bottom one there. So I made all of this connecting hardware to suit these springs. I bought these springs, I made everything else myself. Now the hole spacing in these springs is exactly right, which means any little irregularity in where the cells are means that it's wrong. So it really would have been better if it was a few millimeters wider, these springs. And so you can see here an example. I've had to cut the tabs to suit, so they'll actually fit in between the springs. So I'm going to take this battery module apart today. I thought I'll show you my major design flaw when I designed these modules. So when I first put them in, I had 5 in parallel. I had 45 kilowatt hours of cells, so 200 cells, and put them all in, drove the car for a couple of days, and then something went wrong and I pulled it all apart. And what I found eventually was that I had some shorts. So what it is these cells, I've made this aluminium side here, so partly to keep the cells nicely aligned that way, but partly to keep them aligned this way. So I've got this angle here, I've folded the end of it and pushed the cells up against this bit of aluminium along here. My fatal flaw is that although you might expect the outside of the cell to be electrically isolated from the inside, it's not all the way around. So if you do voltage between here and here, there's nothing. That's insulated. You'd expect it to be insulated. Right at the end here where the fold is, it's not insulated. So that's folded down, and the insulation, which I assume is a mylar coating, doesn't go over the edge of the fold, which meant all of these cells all poking up against this aluminium, there were little currents running everywhere. For some reason, didn't show itself when I just had them sitting in their modules for a number of weeks before I put them in, as I was assembling each module, but it did show up once I started driving the car. So yeah, all the way along here, you find different voltages. Sometimes nothing, sometimes something. So when I found that, I took all of the cells out of the car, all of the modules out of the car, dismantled all of the modules and rebuilt them with some modifications. And so the first modification was I put some Kaptan tape over the corners of these where they touch this metal bit. I also put some contacts, some self-adhesive plastic coating on the inside of the aluminium module. I think that's all that I did. So yeah, just to try and insulate it along there. But for the moment, I'm going to pull this apart. So there's my top cover. So I decided that wasn't quite strong enough, and so that's why I've got these angle pieces on top to put even pressure down over it. And this is just a little bit of stuff to try and, well, both insulate it electrically, since I found that they're not always electrically insulated, but also just to give it a little bit of give, so that can compress just a little bit and, yeah, be nicer to it. And these cells just sit there. What I might do when I rebuild it is I'll put something in between. It doesn't want to be very thick. I've got some Teflon sheet there. I might put that between them, just in case there's any electrical shenanigans going on between them. Now, I've got the original packing with these cells, which is very nice because they're an odd shape. The way this works is you've got these individual PET insert things, and the cells just sit nicely in there like so, one each side, and then you come along and put the next one on top. They're marked which way round they go. And so you put it there, and then the cells sit on top of each other with just the thin layer of PET in between, which means they have a slight bit of compression when they're in this box. It'll fit 20 cells, so that's 10 kilograms on each side because they're about a kilogram each. I've kept this packaging, which has been very useful, and so I'll be able to put all these cells into here as I go. Now I decided that I'll try and keep them in the same order, didn't I? So I'll go left and then right. So I'll keep them around the same way. I'll go left, right, left, and then the next stack left, right. And so that'll be first in, last out. I'll put them back in the same order, except for at least one cell which I'll replace. Now I should inspect them as I go as well. There's a couple of problems that happen with these cells that I've noticed. Now I'll show you that now actually, because I've got some over here with problems. It's this one here. We'll see if you can see it or not. Up here there's a bit of a colouring. So if you look at this one, it just goes around nicely, this corner. Now I think I've got a mylar coating on it, and on this one, on this corner, the mylar's just got a bit of yellow stuff underneath it. So that appears to be, and the cell has leaked through the aluminium, I suppose it is, into the mylar there, and shown and caught it there. So I don't think there's anything majorly wrong with this cell, but who knows if it will continue to leak like that. So I won't use this one. I've written leak on it. I won't use this one as my first choice, but I may use it if I really need to. Now there's another one here. So this is another problem that I've seen here. This is almost certainly one from my first batch that had that problem with the shorting out. So there's a little spot there, and that's a very typical spot for the spots. I've seen those spots a bit. I reckon there's probably a join in there, and it's got hot when it's been shorting out in a weird way. So again, I don't know that that is fatal. It looks to me like a symptom of something that got hot. Now that I've fixed the thing that makes it hot, it shouldn't happen anymore. But again, I won't use this one first. I'll use it after I don't have any good ones, any ones without visible spots. So we've got our familiar patch at the end, which often happens. This one's got a dot in the middle. Now that middle, that dot, lines up with this, so it looks like the nut at the bottom has pierced the cell. There's another mark there from the nut on the other side. The other nut on the same side. So I'll definitely want to take the nuts out of this module. Okay, this can go in my bad pile. Actually, I might discharge this before I throw it away. Might be a good idea. So I've got my little discharging set up now.